All right, welcome to tonight's video. We're continuing part 1 notes, which is on functions. And so here we are, state the domain. And remember, a rational function, the denominator cannot equal 0. So x squared minus 25 cannot equal 0. So that means that x plus 5 cannot equal 0, so x cannot equal -5 or 5. That means it can be -infinity to -5, union -5 to 5, union 5 to infinity. X squared plus 16 cannot equal 0. Well, x squared plus 16 will never equal 0, so the domain here is -infinity to infinity. So even though there's a fraction, the bottom of the fraction can never equal 0. Here you have a square root and a fraction. So remember, under the radical it has to be greater than or equal to 0, but because it's the denominator, it's just going to be greater than 0. Now this is a quadratic inequality. So 4 minus x squared will set equal to 0. And then that's 2 minus x, 2 plus x. So that means x is equal to -2 and +2. So those are our intervals. So if we choose a number -3, it makes this function negative. 0 makes it positive. And then choose a number 3, that makes it negative. So since we want it greater than 0, we want the positive. So that means our domain is from -2 to 2. All right. So 33, same concept, except now it's greater than or equal to 0, which means when we factor, we find the critical numbers, the numbers that make it equal to 0, and those are 2 and 4. So once again, we test. So if we put 0 in, we get positive. 3 in, we get negative. And 5 in, we get positive. And remember, we want greater than or equal to 0. So that means it's from -infinity to 2 inclusive, 4 to infinity. Here, once again, it's going to be greater than 0. So x minus 3, x plus 3. So -3 and 3. -4, if you plug in, you get positive. 0, you get negative. 4, you get positive. So it's going to be from -infinity to -3, union 3 to infinity. And then here, notice there's nothing that can make the denominator equal 0, so the domain is all real numbers. All right, so 37. Now the fraction x minus 2 over x must be greater than or equal to 0, right? It must be positive. So this is a rational inequality. So that means the numbers that make it 0 for the numerator is 2, for the denominator is 0. So now you test. So -1, if I put it in, gives you negative over negative, which is positive. 1 gives you negative over positive, which is negative. 3 gives you positive over positive. So since you're looking for greater than, it's the plus. Now it's going to be from -infinity to 0, but it's not going to include 0 because that would make the denominator 0, union 2 to infinity. 38 is the same way. So the critical numbers here, the numbers that make it 0, are -1 and 1. So when you put -2 in, you get negative over negative, which is positive. 0 would give you, actually when you put -2 in, you get positive over negative, which is negative. 0 makes it positive, and then 2 makes it negative. So the numbers that work here in the domain are -1 to 1, and the 1 is inclusive. The function x squared minus 3x plus 2 over x plus 2, so it's x minus 2, x minus 1 over x minus 2, that has to be greater than or equal to 0. Well, notice that cancels. So basically x minus 1 has to be greater than or equal to 0. But it cannot equal 2 because that would make the original function 0. So we'll keep that in mind. The denominator. So the numbers x minus 1 greater than or equal to 0. If you put in 0, it's negative. Put in 2, it's positive. The only thing is it can't equal 2 as well. So the domain is from 1 to 2 union 2 to infinity. Okay, here you have x minus 3 over x plus 1 over x plus 2 times x minus 1. That's greater than or equal to 0. So you got a lot of critical numbers here, like you have -2, -1, 1, and 3. So when you put -3 in, you get negative and negative, which is positive, over negative and negative, which is positive. So positive over positive. -1.5 gives you positive and negative, which is negative. Negative and negative, which is positive, so it gives you negative. 0 gives you negative over negative, which is positive. 2 gives you negative over positive, which is negative, and 4 gives you all positive. So your intervals here are -infinity to -2. Doesn't include -2 because that's the denominator. Union -1 to 1 union 3 to infinity. So there's your domain. So are these equivalent fractions? Well, the answer is yes, because if you factor, you get x plus 2 times x minus 2 over x plus 2, and notice you can cancel, except at x equals 2, or sorry, -2, because -2 would still make the original function undefined. The domain of each function, the domain of f is from -infinity to -2 union -2 to infinity, whereas the domain of g is all real numbers. F of -2 is undefined, whereas g of -2 is equal to -2 minus 2, which is -4. So the similarities and differences, both are lines, except f has a hole at -2, -4. Using what you talked about in 41, can you write a function f of x as equivalent to g of x equals -5x plus 1 except x at x equals 3? Yes, you can, because you can say -5x plus 1 times x minus 3 over x minus 3. So if you FOIL, you get -5x squared plus 16x minus 3 over x minus 3. 47, the piecewise function. Remember piecewise functions, the changing point is the most important. So if you put -1 in here, 2 times -1 plus 1 gives you -1. So -1, -1's right there. And now less than, so that means like -2 gives you -3. -3 gives you -5. And you have a line, right? Then x squared minus 2. Well, if you put -1 in and square it, minus 2, you still get -1. But then if you put 0 in, you get -2. And if you put 1 in, you get -1. 2 in, 4 minus 2 is 2. So here's your parabola part of it. So there's your piecewise function. One part's a line, one part's a parabola. The domain, since the changing point is a dot, since both numbers are the same, it's all real numbers. And the range is all real numbers. The zeros, what number makes it equal 0? Well, the parabola is where it's 0, so you go x squared minus 2 equals 0. X squared equals 2. X equals plus or minus rad 2. But since it's only the positive one where it crosses the x-axis, it's rad 2 is the 0. The function is increasing, decreasing, and constant. It's increasing from -infinity to -1. It decreases from -1 to 0. And it increases again from 0 to infinity. And it's never a constant. The average rate of change is the slope. So you would go f of 3 minus f of 1 over 3 minus 1. Well, f of 3, if I put 3 in, 3 squared minus 2, so 9 minus 2 is 7. F of 1, 1 squared minus 2 is -1 all over 2. So it's 8 over 2, which is equal to 4. Now, last but not least, finding the average rate of change of this function. So you have to go g of -2 minus g of -3 over -2 minus -3. G of -2, when you put -2 in, you get 4 minus 1, which is 3. So it's -3 plus rad 3. Minus, when you put -3 in, square it, you get 9 minus 1 is 8. So it's 2 rad 2. So -3 plus 2 rad 2 all over 1. So when you distribute the negative, you get -3 plus rad 3 plus rad 3 minus 2 rad 2. The 3's cancel, and you're left with rad 3 minus 2 rad 2. Determine the intervals for which the function is greater than or equal to 0. So negative 3 plus rad x squared minus 1 greater than or equal to 0. So if you square it, so you actually, let's do this first, sorry, before we square it. Move the 3 over, so you get the square root of x squared minus 1 greater than or equal to 3, and then you square it. So then you get x squared minus 10. So then that means x squared minus 10 equals 0. So that means x is equal to, squared is equal to rad 10, or sorry, x squared is equal to 10. And then x is equal to plus or minus rad 10. So when you test, negative rad 10, positive rad 10. So if I put like 4 in, 4 squared is 16 minus 1 is rad 15, which is bigger than negative 3, so that means it's positive. 1 squared is 1 minus 1 is 0, so that'd be negative. And then negative 4 would give you the same thing as positive 4. So the intervals for which it's positive would be negative infinity to negative rad 10, union rad 10 to infinity. All right, that concludes our video for this evening. I hope you enjoy it and you have a good evening.